Hi, Mr. Wartsky again. And remember, you can pause this at any time as you're taking your notes. Please do so, so make sure you get everything down as you take meaningful notes. Today's the second day of chemistry. We're going to talk about atoms, molecules, and compounds, and hopefully get into bonding. So we know that atoms make up elements, and an atom is the smallest individual unit of an element that has the characteristic of the element. A molecule is two or more atoms. So a hydrogen atom, H2, which is a diatomic atom, would be a molecule. A compound has two or more different atoms, like H2O, as in water, would be a compound. And all of these things form matter, solids, liquids, and gases. So how are they defined by shape and volume? Well, a solid has a definite shape and a definite volume. A liquid has an indefinite shape but a definite volume. And a gas has an indefinite shape and an indefinite volume. So you probably need to make a chart to remember that. Again, solids have a definite shape and a definite volume, where liquid has a definite shape. Oh, no, sorry, liquids do not have an indefinite shape, but have a definite volume, and gases have an indefined shape and an indefined or undefined volume. So the atoms are broken down into subatomic particles, which are known as protons, neutrons, and electrons. Now, I abbreviate electrons with an E right here with a negative sign. P's are protons and N's would be neutrons. Oh, let's go back up. So the subatomic particles are defined by mass, charge, and location. So, for example, the proton has the mass of one atomic mass unit. The proton is positively charged, and it is located in the atomic nucleus. Please write that down. It's not on here. Notice that. The neutron has the mass of one atomic mass unit, or AMU. It has no charge whatsoever. It's neutral, and the location is in the atomic nucleus. The electrons have no mass, basically. They have a very small mass, but biologically speaking, we'll say that it has no mass. It has a negative charge, and it is located in orbitals around the atomic nucleus. Now, all atoms of the same element have the same number of protons. That is known as the atomic number, which is a superscript to the left of the symbol. Now, the number of electrons is equal to the number of protons, which basically states that the number of negative charges is equal to the number of positive charges. And hopefully you could surmise that means that atoms would be neutral. The number of neutrons is equal to the mass number, the atomic mass number, minus the number of protons. Now, the number of neutrons can vary within an atom. When the neutrons vary within an atom, we say that that is an isotope. So the number of protons is fixed, but the number of neutrons can vary within the element. They can have different masses. They are isotopes. Now, some isotopes are stable. Others break down spontaneously, and if they do break down spontaneously, they are known as radioactive isotopes. Now, electrons move around the nucleus in undefined paths, which are called orbitals. There are 2 electrons per orbital. Orbitals are found in energy levels, and electrons will move into the orbital closest to the nucleus. Now, as biologists, we are only concerned with 3 energy levels. The first energy level has 1 orbital and contains 2 electrons. The second energy level has 4 orbitals, which means that they have a maximum number of 8 electrons. And the third energy level also has 4 orbitals for a maximum number of 8 electrons. So how do you fill the valence now? The valence shell is the outer energy level. That's what valence shell means. So you can fill the outer energy level, right, by gaining electrons from another atom, by losing electrons to another atom, or sharing electrons with another atom. Now, these are called bonds. So the ionic bonds, you gain electrons or lose electrons to other atoms. Covalent bonds are kind of like the Barney method, and they share electrons with each other. So chemical reactions occur and bonds are formed. Now, the electrons are the only subatomic particle that is involved in a chemical reaction, and a chemical reaction only happens when the atom wants to fill its outer energy level. Now, if the outer energy level is filled, then the atom is stable, basically saying the valence shell is filled, and those are known as your noble gases. Bonds are formed when the atoms fill the outer energy level. I think I said that like 3 different times. Let's talk about the different bonds. Ionic bonds are formed when atoms gain or lose electrons. Now, this is a Lewis dot diagram. Sodium has 1 valence electron here, right? Chloride has 7 valence electrons here. Sodium has 11 electrons total, so 2, 8, and then 1 left over. Chloride has 17, so it's 2, 8, and then 7. So it's easier for the sodium to give up its electron over here to chlorine. And chlorine only needs 1, so it just takes it from sodium. So now, as the sodium gives up a negative charge, it becomes positively charged. It'll become a cation. As chlorine receives an electron, it receives a negative charge, so it will be a negatively charged atom, which is an anion, and it becomes chloride. So it will form sodium chloride. That is an ionic bond. In covalent bonds, you share 1 or more pairs of electrons. In a single covalent bond, you share 1 pair of electrons. A double, you share 2 pairs of electrons. In a triple covalent bond, you share, that's right, 3 covalent bonds, 3 pairs of electrons. So there are 2 types of covalent bonds. We have nonpolar and polar. We have to remember a concept called electronegativity before we can talk about nonpolar and polar covalent bonds. Electronegativity is the pull of an electron to an atom. So if 2 atoms have the same or similar electronegativity, then the electron is shared equally between the 2 atoms, and there is no charge. If there is no charge, it is a non-polar covalent bond. Now, if 2 atoms have different electronegativities, the electron will be shared unequally. That's better English. The electrons will be shared unequally. The atom with the greater electronegativity will have the electron more often than the atom with the lower electronegativity. So the atom with the higher electronegativity will have a slight positive charge, and the other atom will have a slight negative charge. That's a lot to take in. So you might want to pause that while you get all that information down, or you could listen to me again. Now, nonpolar covalent bonds, the electrons are shared equally. An example would be nitrogen, which is N2, or methane, CH4, and the carbon and the hydrogen in the methane have similar electronegativities, so they are shared equally. And there's a diagram down here. Diagrams are good to get. Polar covalent bonds, atoms have different electronegativities and share the electrons unequally. A charge is associated with that. Now, this charge can form a hydrogen bond, which we'll talk about next time. So hydrogen has a low electronegativity, where nitrogen or oxygen have higher electronegativity. We're going to specifically look at water and what happens between water molecules. So here's water, which, we're going to talk about that later. Running out of time. So this ends Chemistry 2 lecture notes. So if you need to watch again, please do so. Thank you.